overload trip. And then we have the voltage selector, 12 volts, 18, and 24. The main switch, the capacitor, we have the voltmeter and analog. Likewise, we have also the in digital. And then we have the capacitor, rectifier, load, and then we have the DC output and then AC output. This is the emergency switch for emergency purposes. So we will switch on now. We will switch on the emergency switch. Likewise, the main switch. So this is the main switch. So there is in analog or in digital also, even in digital meter, you will see the voltage reading as 243. And then the DC output, we have 27.5, and then in AC, we have 21 volts. This is the voltage selector. It means we can select the output without load of DC, it is 14 volts. In AC, we have 11.5 volts without load. And then in the voltage selector, if we will put it into 18 volts, so the DC output without load, it is 20 volts. And then the AC supply, alternating current output, we have 15 volts without load. In 24 volts in our selector or in our voltage selection, we have 24 volts. In DC output, we have a DC of 27.6 volts without load. And then in AC, we have 21 volts without load. Now what we're going to do now, it is to do a connection which is equivalent to the load of DC and likewise AC. So we will turn off the trainer first, then we will start to connect the load circuit. So from this, we will connect both neutral, because our objective, it is to get also the current. So neutral connected to same neutral, and then of course the neutral is directly connected to the neutral of DC supply. Then we will concentrate with the equivalent line. So this line 1 connected to switch 1, and then this line 2 of our lamp will be connected to switch 2. Then we will connect it together for both line, and then connect it to the ammeter, common of the ammeter. The range, it is in DC. So this is our DC ammeter, and then from the positive of our ammeter, we will connect to DC output. So let's try to on the switch of our trainer. So as you will see, you will observe that when it is in off condition, there's no current reading. If I will on the first switch, you have a 94.94 amperes. And also, another current for the equivalent of other side, we have approximately 2 amperes for both sides. So this is the DC load. We have the alternating light, or it is the alternative lights. Now we will we will do a circuit connection also of the AC. So as you will see, you will observe that the AC output, we have 24 or 21.5 without load. So we will turn off the power supply first, then we will do the connection. So neutral to neutral. So from neutral, we will directly connect to one line of AC output of power supply, and then our switch, it is a doorbell actually. How to do the connection of doorbell? This is now the actual connection. So 24 volts AC. So from the bell, then the line of bell, we will connect to one line of the normally open switch, and then we will connect again the equivalent line for the normally open switch. We will connect it to the other side of the AC output. So we will turn on the power supply. So as you've noticed now, we have the input voltage of 343 volts from the company. So here in Oman, we have 243 volts input from the primary winding of our transformer. Then the output of DC with load, we have now 27 volts DC. So the load that we have, it is the alternative lights. So this is an alternative lights. This is 1 and this is 2. So without load, you will notice that there's no reading in the current. But if I will turn on this switch 1, you have now 0.93 amperes. And then another load also, so it is almost 2 amperes. So the output of the AC output of our power supply without load, we have 21.5 volts. So with load, what is our load in AC? In our AC power supply output, our load, it is the doorbell. So the connection that I mentioned already, and I connect it before. Now this is now the output. So there is an equivalent current here. We can connect it using this connection. So this is a voltage. So before you will connect it to the supply, you just connect first this to the ammeter to get the reading. So from here, then another wire, we will connect it to supply. So this is the AC output supply. So when you turn on the buzzer or your doorbell, you will notice that there is a current reading here. When it is in the turn off, it is in zero current. So this is a doorbell, this is alternative lights for our load for DC, and the load for AC, it is a doorbell. So okay, so this is now the principles of the exploded power supply.